like the test to get back?
I do,
Yeah.
yep.
I'm like nervous. I'm about to get like so many test grades back and I have no idea how I did.
Oh. Yeah, it's such a strange semester. I've never had it where, and I still don't know exactly what to do with getting the material back to people. Miles, how are you doing? Yeah, look at this. Look at this. Wow, day before break.
We're off there just for you, Dr. Warren.
This is totally impressive. I actually had a student who I had semesters ago. In my first class, I had the door open like this. They walked by, saw me, waved, and then showed up later with a coffee and a muffin. I'm just like, you gotta be kidding me. This is, who's got a better job than that?
They saw their opportunity and took it.
Okay, let me try to give these back. I don't know how many are coming, but we'll get these. Miles.
Is it 4?
4, yeah, this is 4.
Thank you.
Lorelei. Remember, these are out of 45. There you go.
Oh,
Jonathan. Hannah? I think we're gonna have Laney here. Enjoying the last day live here. Paris is not here, I know that. Avalon, you have such nice handwriting. Somebody who doesn't. Joaquin. Christian. Aiden. Garrett. Shay, I think, is off to Michigan. Christopher. Trey's not here. Laura?
You said we'd be upstairs.
Oh, I lied. Sorry, I lied. Yeah, no, I forgot all about that. Alex, you're more together than I am. Griffin. Where he's not.
Better get that FaceTime going.
I lied. Shoot, I wonder how many people show up on Zoom. Oh, well, I'll put up the.
I mean, everyone probably knows to look down here if you're not up
Can
there.
we FaceTime Paris?
Zach.
Which one?
Swafford? Yep. Literally, there's a Zach right after it.
Wait, Griffin, you
Zach.
have a Zoom meeting?
Huh?
Parker.
I don't think we have that.
Oh, is this the other class?
Here.
Yeah, the one he has back now, that's 4.
Mason.
I don't.
Mason.
We didn't get any quests back for so long.
File. It's a flu shot, not.
Yeah.
Flu shot. Julia. Alex. Jonathan. Michael. Thomas. Is there anybody who doesn't have Paris?
Yeah, she said she was in the Zoom.
Wait, I know what we got out of 45.
That's what you got out of 45. Yeah.
Professor, is there a Zoom today?
No, there won't be a Zoom today.
Okay,
Yeah,
tell
'cause
Paris.
Paris
Oh, Paris, yeah, tell her that I screwed up. See, that's what Joaquin. There you go. Somebody went.
Tell me what that's for.
Yes. Minus 11 and a half. Sorry, I didn't want. Sorry. Shout it out loud.
So 45 minus that? Or
Four-
that's out of 45?
it's 45 minus that, yeah, that's, I do the least amount, Excel does everything for me. Oh, it's the safest thing. Does Paris wanna know what she missed?
I can text her. Probably.
Oh, can we send her a picture of hers?
She already said it was okay, so.
You got it? Or,
You can send the picture.
Okay, does anybody not have
She
theirs?
wouldn't
Does
care.
anybody not have theirs? Do you have Quest 3 graded?
I don't have any,
I don't have
this is the
four.
only question I have.
Okay, yes, I do have Quest 3 graded. Let's talk about this Quest first, okay? Because okay, the average, because we wanna know where we're at, was a minus 9.47, minus 9.47 out of 45. So you kinda know where you're at related to the average. That ended up being a 79, which is pretty high for this Quest, this material. So it means that, I feel like you're learning it. The high grade was a minus 0, which always pisses me off, so just, we won't blame Alex, she's, say, but no, I'm always feel
It's a
weak.
first.
It's a first, yeah, no, typically I don't
last.
give her, and then we had a couple minus 2s, but in general, it was, I thought, pretty well done. It shows that you guys are learning the basic things that I need, from you. So nice job. So now we're done with that quest. Okay. Next quest. Quest 3. Not graded. Parker. This is out of 50. James is not here. Zach Swayford. Jonathan Berry.
You still have the quiz 2 and, or questions 2 with 1 and 2?
Were they online or were they not online?
I think one was online.
Okay. I don't know if I have that with me, but Christian, Henry, Hannah,
She's probably happy to read it because she can just spend more time with her family.
Colin, Garrett, and the keys will go up on these guys, so just Jonathan. Avalon. Michael. Zach. Christopher. Kyle. Thomas. Looks like there are some quests down here. Jonathan. Aiden. Michael. Griffin. Jonathan. Garrett. Steven. Is that good? Are we good with getting stuff back?
Do you know what the average was for quest 3? If not, it's all good.
No, I don't think I've calculated the average for
Yeah, that's
that yet.
fine.
I'll try to get that calculated.
Yeah, no big deal.
it's probably about what it was. It's probably around a 75 to an 80 is kind of what the guess is from
Okay.
historical stuff.
Do you usually end up burning roads at the end or no?
Usually not. Usually it just kind of curve as I go along as I see needed. That's typically what happens. But I don't have a final this year, so usually I can use the final to kind of weigh a cumulative final. So it's just an odd semester. Okay. Who's driving today? Who's driving today? Who's driving today? Okay. If somebody passes you on I-81, it doesn't mean they conquered you. Say that. Say that.
Someone passed you on I-81, it
Doesn't mean they conquered you, okay? You do not need to punish them. You do not need to punish them. Doug is a truck driver. Just when you're on the road and that truck pulls out and slows you down, just think that could be Doug, okay? And Doug calls us the damn four-wheelers. So say that. Yeah, okay, so the physics says the truck wins. So I need everybody back. I need everybody live on Zoom. So it's hard because there's so many small schools and big schools down I-81. When you start at one part of Virginia and go through the other, and you look at all the colleges and universities that are on that road, and everybody's going home today. And so you just have to take it easy and get home. But luckily, it's a nice, beautiful day. A few years ago, it was a bad day, and there were a number of students that had accidents and didn't make it, and so that was just a crushing year for me. Not in my class, thank God.
Even if we're here, we can't come to class.
They won't let me. It kills me. I just so love having students in my space because that's the way I teach. I've taught since 1984. I feed off of your energy. That's why it's important when you do come to Zoom that you have your cameras on so that I can actually see you. Okay? I don't care if you're bathed. I don't care whatever. You just turn your cameras on so that I can see your face, because I give you little tasks and I kind of feel how you're doing by seeing your faces and seeing what you're doing, and then sending you into breakout groups, and so you can learn so much better. This is such a strange semester. I guess we're learning how to survive, but as far as other than that, it's just not a great educational environment. But you guys are adapting. You're adapting. So we're making it, and we got a vaccine literally on our doorsteps. I really think spring semester is going to be a different game. I think by after spring break, we may be everybody live back in a classroom. So super excited about the possibility. As long as we just survive the holidays. Okay, stand up. Stretch. Calculus is about.
Limits, derivatives, and integrals.
Okay, what have we not talked anything about? Integral. So here we go. Look at me. You're not going to like this in the beginning. You're not. Those who've had calculus before know that we're not going to like it. Okay, calculus is about limits, derivatives, and integrals. The derivative is defined in terms of a limit, okay? An integral is defined in terms of a limit, okay? And it's, in the beginning, it's a nightmare. So we're going to write down the definition of the definite integral. And you're not going to like it. In the beginning, you're just going to be scribing because it's all going to be very confusing. Okay, so this is my definition. Can you guys see it, or is there too much glare? Are you guys okay as far as being able to read that? I guess I'll test you. What does that say? Okay, now this is just a symbol. It's just a symbol. And for some, this symbol is scarier than any satanic symbol. Okay, when they see this is something horrible. This says, read this. This is the definite integral from A to B. Right now, it's just a symbol of f of x. And then sometimes people say dx. sometimes they'll say dx. So this is the definite integral from a to b of f of x dx is essentially what they say. Or the definite integral from a to b of f of x is often the way I say it. Write this down. It's a number. Unlike the indefinite integral, it is a number. And it's a number defined in terms of a limit, but you're not going to like this. The limit's going to infinity. And now here's another friend from high school that you didn't like. Summation. The summation starts at 1 and goes to n. But n's going to infinity. So you're like, Dr. Warren, this is impossible. So let's read what we've got so far. That one's a part you understand. Definition, the definite integral from a to b of f of x is equal to the limit as n approaches infinity of the sum of k equals 1 to n. Okay, now let's go back and remember this. We panic when we see this, and we panic when we see that. What did I just say? Some of you are already zoning. You panic when you see that. But I want to tell you guys, this is not such a bad thing. If we start at 1, just give me a number. Give me a number. 2, maybe something bigger than 2. 7. Okay, so we got that. So our sum is going to go from 1 to 7. It starts when k is 1, and what's the number after 1? 2. What's the number after that? And we keep running through that until we reach 7, and then we stop. Now what we put in here depends on k. If k, it doesn't depend on k, then it's just a constant as far as k. So I'm just going to put k squared there. So you guys help me out. So if we're looking at this, the first value, we start when k is 1. So this would be 1 squared. We just plug, almost like function notation. What's that symbol stand for again? What's that symbol stand for? Summation. Summation, which means add. What's the number after 1? 2. So we plug a 2 in, so then it would be 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared, and then we reach 7 squared. And most of my miles.
Is k squared like the function for?
It's kind of like the function, but it's going to get a lot worse. I'm just telling you, like, oh crap, I'm already confused.
Okay.
So are you understanding so far?
Mm-hmm.
Okay, you're like, Dr. Warren, I kind of like the plus notation better. I kind of like the plus notation better. Okay, so what if I did this? Now how do you like that? Now do you want to list all those? Well, Dr. Warren, let's do the dot, dot, dot. Okay, math is proof. Dot, dot, dot is completely meaningless. Plus 50 squared. But this is the way you can think about it. This is the way you can think about it. Wherever you see the k, say that.
Wherever you see k.
We're going to start here at 1. We're going to end at 50. And we're going to plug them in there and do whatever that says. Are you following so far? Are you following so far? Okay. Now, this is where it gets a little bit more complicated. A little bit. And then it's going to get a lot more complicated. Okay, I'm going to make this like this. What's that? Ice cream cone. Okay, so that means you like it. That means you like it. Sub k. Ice cream cone sub k. And we're going to do the same thing here. Wherever we see the k, we're going to start with
1.
We're going to end at, and what does that symbol mean? Summations. So we have the k, which is a little baby subscript. So we would have ice cream cone sub 1. Are we done? And please say sum. plus
Ice cream cone
ice cream cone
sub
sub
Two.
2 plus, and then I think you guys are getting it, like that. Are we following so far? Are we following so far? Now we're ready to, unfortunately, go back to this thing. Okay, so let's read again.
Definition.
The definition of the definite integral from a to b of f of x dx is equal to the
Limit as n
the sum as k goes from 1 to n, and now we see the disappointment. N's going to
infinity.
So we had 50. Is 50 even close to infinity?
No.
No. Is 5 even close to infinity? No. Now here's the thing. It's f. You're like, oh crap, there's a function. Okay, guys, we've been doing nothing but dealing with functions. What's the definition of a function? Dr. Warren, I hate you. A function is a relation. Very good, Miles. What's the relation's job? Assign, and it assigns to each element in one set called a unique element in a
Ring.
second set called the ring. So I think that was okay.
Can you repeat what, like, the whole thing is defined as again?
Yes. Definition. Okay, Julie, then we got the integral from a to b of f of x dx. We'll even drop the definite. The integral from a to b of f of x dx. This symbol everybody knows equals the limit as n approaches infinity of the sum of k equals 1 to n of f, and this is where, oh, it's a function, and you're like, oh crap, f of x sub k, which is just kind of like what we had here, but instead of having ice cream cone sub k, we've got x sub k. And now here's the thing, the moment we go Greek, people think they can't understand it. Times delta x. Times delta x. I think it was the stupid geometry class where you were introduced to the angle theta, where everybody started hating Greek, okay? You know, except for sororities and fraternities, nobody wants to see a Greek letter in any of their classes. Okay, so this is a delta. This is a delta. It's a capital delta. Delta x, say that.
Delta x.
Say that.
Delta x.
Okay, so let's, Lainey, are you with me? Julie, are you with me?
Yeah.
So we're gonna read it again. The integral from a to b of f of x dx is equal to
The limit
as
approaches infinity
of
the sum
k equals 1 to n of
f of x
sub k times delta x. Okay, so now we're gonna come over here, and I'm gonna pretend like I'm at MIT, and I'm like an intelligent professor, and I push the board up like, wow, okay, this, you know, some good learning is going on in this room. We're gonna do the same thing. K is gonna go from 1 to, what's that number up there? 5, because we don't wanna list more than that. And we're just going to look at that. How many people recognize they do not see a K with the delta x? How many people do not see a K? If you're seeing a K right now, then you're seeing a ghost, and we have deeper issues, okay? Or you've taken LSD, and we've got even deeper issues. How many people realize there's no K with the little f there? The only K is with the x. So let's just write this out. We would start again with K equals 1. So we would have a f of x sub 1, and then times delta x. Are we done? And please say no. Then we would have a plus, and you guys see if you can't write down the rest. And this is when it's so good to see your faces when you're actually, you guys see if you can figure out what the rest of the terms in the sum would be. Can't believe this is our last class together. I mean, not technically, but physically you're gonna be two-dimensional for the rest of the semester.
This seems like the worst unit to do online.
Yeah, they would pack that in at the end, yeah, no. But you guys are gonna do okay. You, don't panic. It just feels really uncomfortable in the beginning, but don't panic. Dr. Warren controls the circus. It's my circus. Okay, sheet, look around, don't breathe, but sheet, look around, see if you've got the same thing that others have. See if you've got the same thing, yeah, you just lay your sheet off, Zach there.
It's okay. You know,
X sub 1 delta X. Okay, we'll go with that.
I'll send a note on.
Okay.
Okay, I'm ADD, so I can't list them all. I'm ADD, so I can't list them all. How many people had that term at least? How many people had that term at least? Okay, then how many had all the way out to 5? Now here's the thing, guys. Ours were going out to n for each natural number, like 100 and 101, but n's gonna go to infinity, and you're like, Dr. Warren, this is a dumb definition. There's no way to actually calculate this. This is a stupid definition. There's no way to actually calculate this. And I'm just saying, well, hold on. Now, let's explain who this delta x is, because right now it's just this bizarre quantity. Read this to me again.
Definition.
The
Definition.
integral from a to b of f of x dx. Now, how many people are glad they came to class today and aren't learning this from the video later on, that you're actually here? Yeah, no. I feel bad for the other like 20 people that aren't in class right now. Okay, so write this down, this is part of the definition, this is the longest definition of the entire course, where delta x is equal to. Now we're finally going to explain who delta x is. Well, it's b, the number that's up here, it's b minus a. And you're like, Dr. Warren, okay, that's not bad. It's just b minus a. We're not done. Divided by n. Divided by n. It's b minus a divided by n. Now, who's n? Well, n's the thing you're taking your limit of. Now, notice as n goes to infinity, this denominator is going to get really, notice as n goes to infinity, this denominator is going to get really big. Now, I've got to ask, if I said, guys, I will give you a yearly salary of 1 over $1 trillion, would you be excited?
No.
If I said, I'll give you a yearly salary of 1 over $1 trillion, would you be excited? No, because that would be almost nothing. Essentially, it would be nothing. So as n goes to infinity, this delta x goes to 0. So as n goes to infinity, this goes to 0, but we're adding up infinitely many things. So it's very similar to the definition of derivative. In the derivative, the denominator goes to, we've already forgotten, well, I'm done with the quest. No, in the derivative's coming back. In the definition of the derivative, f prime of c is equal to, have I taught you nothing? F prime of c is equal to the limit, very good, as x approaches c of f of x minus f of c divided by, so as x goes to c, where does x minus c go? As x goes to c, where would x minus c go? 0. The denominator is going to 0, just like what we have here, but we don't have the numerator going to 0. It's b minus a, and that's taking place up in here.
Wait, so you said as n approaches infinity, delta x is approaching 0?
Yes, as n gets really big, b and a are fixed, like maybe it's 5 minus 1, 4. And so then it would get really, really big. So again, guys, all we're doing today is unpacking this. All we're doing is unpacking this new unit. Okay, so we've explained who this is. You know, like, I don't get it. You will. Okay, we've explained who this is. We have yet to explain who the x sub k's are, and that's what we're going to do right now. And x sub k is equal to a plus k times delta x as k goes from 0 to n. So write that down, As k goes from 0 to n, and now you're going to be happy that's the end. You're going to be happy that's the end. We have finally reached the end of the longest definition of the course. So let's unpack this part. I guess let's read the whole definition together. Finally, we reached the end. So you guys read. How many people are comfortable now? Ready, let's go. Definition, the definite
Integral
from
a to b
of
f of x dx
equals the
limit as n equals infinity
of
the
the
sum as
k goes from 1 to n of f of f sub k times delta x, where delta x is equal to b minus a sub over n, and x sub k is equal to a plus k times delta x, as k equals 0. And I guess maybe I should probably change that to 4, using proper language, for k equals 0 then. Okay. So let's unpack this. Let's unpack this and let's unpack that. Suppose we've got this. Stand up, like nobody sense the boredom, even though we've got the windows open. I sense the boredom snuck in. There was actually a bug that was running around the room either earlier today, I don't know where it went. But I don't think it's around. It didn't look dangerous. Stretch. Look at somebody and say, wake up. Say, drive safe. Don't give your family COVID. Say that. Say, don't give your family
Don't give your
COVID.
family
Sit back down. Did anybody get tested?
Yeah.
Did you get anything back yet?
Yeah,
No.
negative.
Negative.
I mean,
That's
unless
what
I
I
got
want
it,
to
like,
hear.
yesterday.
Negative. Okay.
Really? You might have.
So let's put in some numbers. Give me an A, and if you say A, I'm gonna vomit. Okay, give me an A. 1. Okay, I hear that. Give me a B. 3. So we're looking at the integral from 1 to 3. Okay, so now, let's just keep this arbitrary right now. So we're here, now this is equal to the limit as n goes to, this is equal to the limit as
n goes to infinity.
n goes to infinity. But right now, guys, I don't want to take it to n goes to infinity. So we're going to do an approximation. And it's going to be a very bad approximation. Give me an n that we maybe would make an approximation with. Give me a number up here. Give me an n. 20? I hear that 20. Okay, so we got a 20. This is going to be an approximation. Now, what follows the sum in the definition? Don't you dare look at the board. Don't you dare look at your notes. What follows the sum in the definition? F of x sub k times delta x.
On the left side of the equation, where does the delta x come from?
The delta x is part of the definition, Miles.
Oh, okay.
And we're going to start unpacking that right now. So now, let's look at delta x. Where delta x, now let's look over it. Delta x, you've probably forgotten already. So look at the board, b minus a divided by n. So now you guys help me out. Who did you guys choose? Who did you choose as your a?
1.
And who did you choose as your b?
3.
So it'd be 3 minus 1. And who's the first n that we're using? 20. And you're like, that's 1, okay. Now, does that look a little more familiar, like back to elementary school kind of stuff? How many people could simplify that? What is it when it's simplified? You said you could. You guys.
1/10.
1/10. Does everybody understand that that's 1/10? Like, okay, Dr. Boyne, that doesn't seem so bad now. That doesn't seem so bad. Okay, now the x sub k's. Where's the x sub k's in the room? The definition. X sub k is equal to a plus k times delta x. So let's just write that down. My x sub k's are equal to a plus k times delta x. So now you guys help me out. My x sub k's are going to be equal to a. Who did you guys pick a to be? Who was your choice for a? 1 plus k. And what did you simplify your delta x to be for this very specific value of n? 110. Now this is as k goes from 0 to n. So this would be as k goes from 0, and who's our n right now? Who's our first n that we're using? 20. So let's list all these. We're not going to do that. But let's list a couple of them. What's the first value of k? 0. So I would have x0 is equal to 1 plus 0 times 1/10, which would just be 1. x1 would be equal to 1. Who's k now? 1 plus 1 times 1/10. Now let's do this hard math, and I know it is hard. We would have 1, how many tenths are in 1?
10 tenths.
10 tenths plus
1
1 tenth would be how many tenths? 11 tenths. x2 would be equal to 1 plus 2 tenths, which would be 12 tenths. And are you getting the idea? Are you getting the idea? Because I'm running out of chalkboard. But I guess I could do this clever. Well, that wasn't so clever, but it's freaking board. Look at me. x3, quality teaching, would be 1 plus 3 times 1/10. And how many tenths would we have there? Okay, and now I'm bored. Okay, ... What would be the last value of k? What's the last value of k? 20. And that would be equal to 1 plus 20 times 1/10, which would be equal to 1 plus 2, which would be 3. You're like, Dr. Warren, this is insanity. This is insanity. This definition's insane. How can you actually do this? You'll never be able to calculate it. And without Newton, you're right. If Newton wasn't around, we wouldn't be able to. Stand up again. Stand up again. And you guys have already learned so much. Dr. Warren, I've learned nothing. You don't understand. I've learned nothing. Sit back down. Read. Definition, the definite integral from a to b. So over here it would be the definite integral from 1 to 3 of.
F of x dx.
Oh gosh. Stop. Oh my gosh. No wonder you guys are confused. Ugh. I was already jumping over the approximation, so let's read it correctly. It'd be the definite integral from
1 to 3.
1 to 3 of
f of
x
x
dx. And it's approximately equal to the sum as k goes from
1 to 20.
20 of f of x sub k times delta x. And you're like, well, who the hell is delta x? And you're like, well, that delta x would be equal to
110.
110. 3 minus a, b minus a over n. Well, who are these x sub k's? Well, the x sub k's are defined as a plus k delta x. Okay, now here's the thing. What do we do with the x sub k's? What do we do with the x sub k's? What do you do with the x sub k's? I'll keep asking. What
Use some-
do you do with the x sub
add
k's? Dr. Wynn, I don't know. Well, let's write this out. No, Dr. Wynn, let's not do that. Let's write that out. Let's write, come on, you guys help me out. Let's write that out. We would start with k equals 1. So it'd be f of x sub, I'll get out of the way, it'd be f of x sub. We're going to start with 1 times delta x. Okay, but we've just found delta x to be, for this very, delta x was 1/10, and x sub 1 was 11/10. But we're not going to write that down. Are we done? Are we done summing? Are we done summing? So the next term would be
F x sub 2
times,
delta.
and now I'm kind of bored. The last term would be when k is 20. Mason, are you still with me? So we would have an f of x sub, what, guys? We'd have an f of x sub what? Write down what you think. Write down what you think would go into. This is active learning, right? Get you guys doing stuff. I know I never keep the door open or have the windows open because I'm like I'm like squirrel. The moment I look over, people walking by. They're having more fun than you. F of x sub 20. Are we done? Times delta x. Okay. Who is delta x? 1/10. So what I want you to do is wherever you see the delta x, I want you to put the number 1/10. And then who is x sub 1? 11/10. So do your best to put in the numbers that we have right now for this. So right now, this has just been an entire day of unpacking a single definition. Okay, I'm hoping everybody got, did anybody have the 1/10? If you didn't have the 1/10, we're screwed. Did anybody have an 11/10 in there? Did anybody have an 11/10? And then we had 12/10. And then I know you didn't, but it ends up being 30/10, which is the same thing as 3 times 1/10. And you're like, Dr. Warren, what does this operation mean here? Well, what's the operation between that guy and that guy? What's the operation between those? Multiplication. Now notice, I ask, what do we do with the x sub k's? This is important. So wake up. This is important. What did we do with the x sub k's?
Added.
We didn't add them, we plugged them into we stuck them into the function. So say that.
Put them into the function.
We evaluated the function at them. We plugged them into the function. So this is a range value. Say that. We talked about a function. This is coming out of the function times 1/10. What's coming out of the function when we plug in? 12 tenths. Isn't 12 tenths? I mean, that's what we're gonna plug that into the function, and then we're going to multiply that number times 1/10, and then we keep doing that. You're like, but Dr. Warren, but n's going to infinity, and we're just at 20. You're never going to be able to do this. And you're right. Before Newton, there wasn't. Before 1700, doing something like this was completely impossible. And I can't imagine when Newton was at Cambridge and he was first explaining the fundamental theorem of calculus. I mean, these were bright guys. But when he was explaining what a couple of the applications were, I can imagine that people were like pissing their pants. These were mathematicians. They had no lives. I mean, they loved math. And when they were actually beginning to understand, Newton was who in Man in the Millennium? Second in Man of 1,000 Years. Okay, so what we're going to do is we're going to unpack this a little more, then I'm going to let you go on break. Yes. Now again, you're like, Dr. Warren, I'm really sad I came to this lecture. Oh no, you're not. Think about the poor people who didn't come to the lecture. They're going to read this, and they're going to say, oh, it's all Greek to me. It's all Greek to me, which means I don't understand anything that it's saying. They're going to see this Greek letter that we use for summation, and they're going to panic. They're going to see that, and they're going to be like, oh, hell, what is that? They're going to be, what's this, and what's this? When they write down this definition, they're going to be like, I don't know what I'm doing. We're going to end with this. We're just going to look at a very simple picture. And I think with it, you can begin to understand at least what the number represents. So for the last time in a physical classroom, stand up, stand up. You're making this difficult class. Yeah, no, it's difficult for me. It's very hard for me to say goodbye. That's what I struggle most with.
It's just this very well could be the last time any of us see you in person.
I know, Mason. It's yeah, sit back down. But I'm always, I mean, the bottom line is, once you're my student, and I'll talk to the camera too, once you're my student, you're always my student. Guys, I mean, well, I'll tell them more, but I mean, like, I have a futon in my office, just because I could fit more students on there, as far as like, I could put 7 across when the office would get packed. I gave up a chalkboard just to be able to have more students in the office at one time. Now I can't have any student for office hours. But I've had students, I don't know what it is, maybe it's just I'm such a screw up that people trust me, but I will have, my students come and they trust me. So literally I'll have students in there and they'll pour out their heart. I mean, because I mean, you might think, okay, well, you're on a campus of 20,000 students, of people your own age. This shouldn't be a lonely place, but oftentimes it is a lonely place. And you have students going through really, really adult, difficult things. And for sometimes it's their first time away from their family, and they're just beginning to realize the adult things and some of the difficult things that happened to them in their past or are happening to them currently. And they'll come to me and share. And I've heard literally, 1984, I've heard literally almost everything. The only thing, I've heard Dr. Warren, I've got caught dealing. Okay, and we dealt with that, okay? They went to jail after graduation, but they did go to jail. And now they're teaching at a community college. I'm not going to say where, okay? But they're okay. I've heard I'm pregnant. I've heard that, that I've been arrested. I've gone and bailed kids out of jail because they got caught drunk walking, which still blows my mind. You're gonna arrest somebody for drunk walking. Okay, but literally, I've heard almost anything. So you can always come to me. I don't have good advice. I've got lots of scars. But you can always come to me, and you know, oftentimes people just need an ear. Oftentimes they can find their own way if you just let them talk and just feed back a little bit of information. So I don't want you walking around this campus sad. Or you understand? You always have my office you can come to. And like I don't judge you by how you do in calculus as a human being. I mean, that's absurd, right? I mean, I have students that failed my class. They come back for homecoming, and we go out and party. Okay, we go out and we gather. Okay, let's just leave it at that. We gather. Okay, I have students who've gotten A's. I've got students who've gotten A's that literally I would walk across the other street because I would never want to talk to them ever again. Because I've seen them use their gifts for evil. Okay, I've seen them use the gifts they got for evil, not good, hurting people. In relationships. Okay. Just.
Calculus in a bad way.
Yeah, no. They didn't use calculus. They used other ways to manipulate human beings. Okay. Well, enough of that. So you always have me. Yes. Okay. We're going to end with this picture, and I'm hoping this picture can start unpacking a little bit of this definition for us. We know we have a function, true or false. We know we have a function. So draw yourself an XY axis. And draw yourself a function. Just draw yourself a function. Make it above the axis, the x-axis. Now, since the x sub k's are going into the function, they're going to be domain values. And these domain values depend on delta x. They also depend on a, but delta x depends on b and a. So give yourself an a and a b down there in your domain with b bigger than a. Just mark an a and a b. Just mark an a and a b. Okay, now what I want to do is I want to unpack this only for n equals 4. So write down n equals 4 and put a box around it. Yes. So you guys, what have I told you to do so far? I draw a xy, and then draw a function f. Yours doesn't have to look like mine. Then what did I say? Draw an a and a b. Then I said pick n equal to 4. And then I said what? Draw a box around it. Now delta x is equal to b minus a over n, but n is now, we just picked it to be, boxed it as 4. So we're taking this interval, b minus a, and we're chopping it by 4. So we're taking this distance, and we're cutting it into 4. So it's almost like we've just taken this, chopped it in half again. We've cut it into 4 equal pieces. The length of each one of these pieces is the delta x. So mark a delta x above those 4 pieces. The length of those pieces is delta x. Now x0 is a plus 0 delta x's. So this would be x0. x1 is a plus 1 delta x. But this would move me over a delta x, so this would be x1. x2 is a plus 2 delta x's. So this would be, that x coordinate would be x2. And I think you're getting what do you think that x coordinate would be? What do you think that x coordinate would be? x3. What do you think that x coordinate would be? x4. Okay, now let's plug these into the function. Let's plug these into the function. And then I'm gonna let you go here. Let's plug these into the function. Here's x2. How could I find f of x2? Did I teach you anything in this class? Here's x2. How do I find f of x2? You go straight up and you go over. So this would be like f of x2. So let's just look at that term right there. Read this to me. Times delta x. How many people have delta x's in their drawing? How many people have delta x's in their drawing? And you're like, well, Dr. Warren, this is delta x. It's the length here. It's the length there. Now this is f of x2. It's the distance from here to here. Now what I want you to do is draw straight lines, straight up, from all of your x sub k's. Draw lines straight up from all of your x sub k's. Now, put little dots at the top of where those lines intersect that function. Now what I want you to do is start at the right and draw rectangles. You always start at the right and draw rectangles, just going straight over. Now, you guys help me out. Back in elementary school, how did you learn to find areas of rectangles? It's the one shape you could probably find the area of. How do you find the area of a rectangle? Length times width. What is the width of my rectangle?
Delta x.
And what's the width of all of my rectangles?
Delta x.
Now, what represents the length? You're like, well, Dr. Warren, it's that distance right there, right? But isn't that the same as that distance right there? So the area of this rectangle would be length times width, or it would be f of x sub 2 times delta x, length times width. What would the area of that rectangle be? And I promise I'll let you go. What would the area of that rectangle be?
F of x sub 3.
Times, what would the area of this rectangle be? Times delta x, and the area of this rectangle. Now what if you added those together? What if you added all those together? You would have that right there. So what we see is that this is not the area under the curve, but is an approximation to the area under the curve. And if you add more rectangles, would the approximation get better? If you added more rectangles, would the approximation get better? And if you could do an infinite number of rectangles, might it be equal to the area under the curve? And that's where Newton started. Okay, guys, you have a safe break. Thank you so much for coming as many times as you did during this crazy semester. Thanks, Lainey.
Dr. Warren, is that just like a Riemann sum?
It is a Riemann sum.
Okay.
We're not using such horrible words. Yeah. Have a nice break.
I understand the whole mind now. But when it's true, it goes so mine.
Have a great break, Zach. Julia, have a good break. And hopefully you don't have to travel too far.
I do like 6 hours there.
Oh, that's horrible.
Yeah.
I'm sorry. Where's yours at?
New York.
Lower New York or?
Coming to Salt City.
Okay.
I've got some kids
Sorry.
who go home there.
Lorelei, you have a good break.
I will. I just have one question. Why is this on false?
There.
No, you're missing the F prime.
Yeah, so it's false, because we're missing the F
Oh, that's not the one you missed. It's that
Oh,
one.
well then.
Yeah, it's the second one.
Good point, good point. Anyways.
No, it's my slide.
Lauren, thank you for everything.
No,
I
Alex,
just had to
thank
talk to
you.
but
No,
thanks for
you
making
guys,
helping
no,
us
Alex,
enjoyable.
no, you, yeah, you got a great mind, I wanna see what you do with it, I wanna see where you go,
Aw, thank you.
no, it's,
So for some task homeworks that I didn't do well on, am I allowed to like ask you for any section on this?
that you didn't get them done?
No, I did them, but they just like weren't super good scores.
There's not too much I can do, Miles, about that.
Okay.
If you've done them already, there isn't much I can do.
Alright.
You might send me an email,
Okay.
and I might see if there's something that I can maybe
Like they
do.
or something, okay.
I don't know exactly what, but,
Okay.
but,
Alright, yeah, I'll send you an email, thank you.
no, Miles, you're
I'll just
growing.
give you this. Thank you
No,
so much for
Miles,
everything.
Miles, no, thank
I
you,
appreciate
man,
it.
thank you, no,
It's, you made me like find interest in math again, so.
it's such beautiful material, and this is your last math class probably for your whole life, you know, and
We'll
so,
see.
so if you can sell it to your kids,
Yeah.
you know, and if you take more math, then you're like, that is my dream come true right there.
For sure, no doubt. Well, thank you for everything.
Thank
I
you,
really appreciate
Miles.
it.
Just wanna say thank you for everything.
No, Mason, thank
You
you.
managed to make the math class the class I look forward to.
Oh, that's absurd. Hey, bless you, bless you.
Every grade
You
break.
guys just made my day. You guys just made my day.